Okay, we will continue our topic now by discussing the applications under electric circuits. So if we will review our circuits 1, we have discussed the Ohm's law. So if you can still recall, in Ohm's law, if you have this voltage source and resistance of the wire, we can solve for the current that is flowing in the value of your R. Now, the current flowing in the circuit is simply the velocity, the voltage divided by your resistance. That is in Ohm's law. But in reality, the wire will have a resistance. Sometimes it has a capacitance and an inductance. Okay. So still, this is your velocity. That is your voltage source. Now we will label it as R. We will label it as C, and we will label it as L. Now, the total current that will flow on this circuit is equal to the voltage source divided by the total impedance Z. So impedance is actually synonymous to your resistance. Impedance impedes the flow of current. In this case, resistance resists the flow of current. So if you are impeding the flow of current, you are actually resisting the flow of current. Now, take note of this. And this C and L will be represented by a complex number later on. Okay, now, for series circuit, okay, we'll draw the series circuit. Assuming I have here R1 and R2, and this is your voltage one. Now, for series circuit, the current that flows through your R1 is the same current that will flow through your R2, and we will label that as your I. So your series circuit, I here is constant. Okay, now to solve for I, all you have to do is find the total resistance, the voltage over the total resistance. So I will label this as R tot. I equals the voltage all over the total resistance. So if this is the combination of your capacitance and your inductance, this will become, take note, if this is a series circuit, a combination of capacitance, we will label that as XC, inductance, we will label that as XL. Now, C here is your capacitor, L here is your inductor, that's the symbol. But if you have XC, we call this one your capacitance. If you have XL, you call this one your inductance. That is equivalent to V all over the total impedance. Okay. You will review this in your circuit analysis. Now for parallel circuit, let's have this one. For parallel circuit, take note when we say parallel. Now I have a voltage source here. Parallel, okay, meaning to say they are connected with the same branch. Okay, this is the branch, and all elements are connected in the same branch. Now we will label this as R1 and we will label that as R2. Now for parallel circuit, the total current will flow here. Now we will label this as the total current. Okay, and when the current passes this junction, the current will split into two. Now we will label that as I1 and I2. Take note, for parallel circuit, the voltage here will be the same here and the same here. So meaning to say, for parallel circuit, the voltage, no, are the same or is constant. Now to solve for I1, that is just the voltage, no? According to Ohm's law, that is just the voltage over R1. To solve for I2, that is just V, since the voltage is the same, all over R2. Now to solve for the total current, that is just I1 plus I2, or that is V over R1 plus V over R2. Or you can take out V, and then this will become R1, 1 over R1 plus 1 over R2. The same will happen if the circuit is composed of inductors and capacitors. So for now we will be focusing on resistance and capacitance. Okay, let's have an example here. Okay. Sketch the Phasor diagram of I and V in the circuit shown. Okay, I will introduce you to the Phasor diagram. The Phasor diagram is actually your argon diagram, but in electrical circuit terms. Like for example, okay, by the way, I will draw the circuit here. The circuit is very simple. I have here a voltage source. Now, I will label this as 12 angle of 20 degrees. Okay. Of course, now I have here a resistance of 2 and a capacitance which is equal to negative 1/4 J. Now, we are going to solve for the current I versus, we will solve for current I. Sketch the Phasor diagram of I and V in the circuit shown. Since V is given here, so we need to solve for the value of I. Now, you start your solution by, of course, this is the start of our solution. Okay. How are we going to solve for I? Since this is a series circuit, we need to add all of these resistance and capacitance. We call this one your impedance. Your impedance, your I now can be equal to the total voltage in the circuit divided by your impedance. So in this case, the total voltage is 12 angle of 20 degrees. This is 12 angle of 20 degrees all over the impedance here. Now you can add the impedance, that is J 1/4. Now to solve for I, all you have to do is to get your calculator. Please try to solve this problem in your calculator. Take note. Now we can directly solve this even they are of different forms. Like, 12 angle of 20 divided by 2 minus, I'm sorry, this is fraction J, this is I, then where is I, J over 4. So press equal sign. Oh no. Okay, I will label this as 1/4 multiplied by I. What is different here? Okay. This is the minus, not negative. Okay. Oh yeah, I have here my values. So we will change this to decimal point. So this is 5.95 with the angle, take note of the angle, 27.13. So this is 27.13 degrees. That is your current I. Now, if we are going to plot this in our Phasor diagram, this is our Phasor diagram. So your Phasor diagram is your diagram representing your current and voltage. Now first we will plot the voltage, that is 12 with an angle of 20 degrees. Okay, I will label this as your voltage. This is 12 angle of 20 degrees. Now for the current, we have 5.95, that is somewhere here with the angle of 27 degrees. Okay, this is 5.95 with an angle of 27.30 degrees. This is your current and this is your voltage phasor. So this is your phasor diagram. So any questions? Okay, I hope you understand the topic for today. Now let's move on and we will try to solve another example problem here. But this time we will be solving parallel circuit. So I will give you an example of this parallel circuit. So example number 2. So for our example number 2, we are going to sketch the phasor diagram of I, okay, and V in the circuit shown. So I have here a parallel circuit. Okay, the values are 4 minus 2J. Okay, and the angle here is 12. The voltage here is 12 angle of 30 degrees. Now, our goal is to sketch the phasor diagram. Now, I thought and your voltage. So this is your total current. Take note, total current is the current that is leaving or entering your voltage source. Now, if the current will split from this junction, this branch will become, the current that is flowing on this resistor will become I1, and another current that is flowing here, we will label that as I2. Now, in our parallel circuit, the voltage here is the same here and also the same here, which is equal to 12 angle of 30 degrees. So your solution here is very simple. Try to solve for I1 first. That is the voltage across here, that is 12 angle 30 degrees divided by the total resistance, which is 4. So this will become 3 angle of 30 degrees. Now solve for I2. So I2 is the voltage there, that is 12 angle of 30 degrees divided by minus J2. Okay. So get your calculator and solve for the voltage, or the current I mean. So 12 angle 30 degrees, now we will divide it by minus 2I. Okay, taon. Okay, 12 angle 30 degrees divided by minus 2I. So press equal sign and you have 6 angle of negative 60 degrees. We have 6 angle of negative 60 degrees. Now, if we are going to solve for I thought, so this is your I thought, not the other, not what you think. This is I1 plus I2, that is 3 angle of 30 degrees plus 6 angle of negative 60 degrees. Now use your calculator. So since I have here 6 angle of 60 degrees, I will just add 3 angle of 30 degrees. That will be my total current. So my total current is charan 6.71. This is 6.71 with an angle of negative 33.43 degrees. Negative 33.43 degrees. That is the total current of the circuit shown. Now, since that is negative, no, in the Phasor diagram, now I can draw that here. And this will represent my I thought with a magnitude of 6.71. I'm sorry, with an angle of 33.43 degrees. Now, for my voltage, this is 30 degrees. This is my voltage source, that is 12 angle of 30 degrees. Take note of the difference of the angle between your voltage and your current source. We can say this is negative 33.43 degrees and this will be 30 degrees. Now the voltage across here between them is 66.43. We can say that the voltage is leading the current by 66.43 degrees. Or you may say the current is lagging. Okay, lagging kinaulihi. Lagging by 66.40 degrees. You can say the current is lagging the voltage by 66.43, or the voltage is leading the current by 66.43. Am I clear? Okay, that's it for today. I hope that you will answer all your assignments and submit it online. Okay, good luck for your quiz number 1. That will be this coming Saturday. That is posted in your Canvas course.